Hello, geometry students. Welcome back to another video lesson where we continue to look at the properties of trapezoids. Had lots of questions yesterday about maybe expanding this a little bit more and how do we do some things. So we're going to combine this with some of the proofs, with one proof of trapezoid, and look at what does it mean kind of as we look for some of these different problems. Now, one of the things I think that we have to make sure that we understand is from this quadrilateral hierarchy is that each quadrilateral below another inherits the properties of the one or more from above it. So for example, when we did the kite and we talked about the kite having a line of symmetry, this longer line, that would be the same, having more symmetry for rhombuses and square, because if it's below it, it inherits the properties up above. All right, so trapezoids, we talked about having those base angles congruent and that we could cut them in half by bisecting. Same thing for rectangles and squares and things of that nature. So it inherits. The other piece, all quadrilaterals have 360 degrees. All four-sided shapes are going to have 360 degrees on the interior. So make sure that you know that as well, because that plays an important part in these two examples and how we might find given angle measures. Now, the nice part in this one is that on the left, we know that this is a trapezoid. Find the length of the angle indicated for each trapezoid. So they're telling me they're trapezoids. That's the evidence. They're telling us it's a trapezoid. And if it's a trapezoid, this one in particular is isosceles because the opposite sides here are congruent, meaning this angle is congruent to this angle, or that this angle is congruent to this angle. But they're asking us to find the question mark. If these two sides, the left and the right, xy is congruent to wv, that means that this yv is parallel to xw. They have to be parallel by definition of a trapezoid, and they can't be the two sides that are congruent. So what that tells me even further, and this was the property of trapezoids yesterday, is that these two angles have to total 180. They have to total 180. That's the rule of any trapezoid, right? They have to be 180 because the two lines are parallel, and those are what we call same side interior. The two same side interior have to be 180. That would mean angle W down here, if I already have 70, would have to be 110. So you can see how applying a couple different properties of the trapezoid helps us find that missing angle. In the second one, all we know is that it's a trapezoid, that the top is parallel to the bottom. Well, they tell me R is 8x plus 34, and that Q is 6x minus 22. So what do I know about these two? They have to total 180. So if I add them together, 6x minus 22, and I add to it the other angle, 8x plus 34, I know that together those two angle measures, whatever they end up being, have to total 180. And now I'm going to use my algebra problem solving skills. Combining like terms, 6x and 8x is 14x. A negative 22 plus 34 is plus 12. And that's going to equal 180. Or 14x equals 168. So what would our last step be in solving this particular problem? Well, we would have to do 168 divided by 14. Come on, divide by 14. Divide by 14. And that tells me that x is going to equal 12. Now, what we have to be careful of is to make sure is that all they're asking us. Well, notice, they want me to find the measure of angle R. So if r is 8x plus 34, 8x plus 34, I've got to plug in that 12. 8 times 12, let's see, 8 times 10 is 80, and 2 more is 16, so 96 plus 1, or plus 34 equals 130 degrees. So angle R would be 130 degrees. So hopefully, again, you see that they've got that consecutive pattern there, and because of that, because they're same side interior on parallel lines, they have to total 180. All right, now we're going to step into a proof. And again, what I want to encourage you is, number one, identify what you're trying to prove. What is it that you have to show? What's the definition? And then what are the hints that they give you? So we're given that it's an isosceles trapezoid. ABCD is isosceles. That's really, really important. With bases AD and BC being parallel. They also tell me that angle BAK is congruent to BKA. We need to prove that BKDC is a parallelogram. So we need to prove that it's a parallelogram. The definition that we have to come up with, the evidence that we need for parallelogram is we need to show both sets of sides are parallel. Both sets of sides are parallel. And I'm going to type this out because it's just going to be sloppy. Parallelogram. Both sets of sides are parallel. So we have to prove that somehow. The nice part is that we already know AD is parallel to BC. So in this, if this is a parallelogram, we already know that those two sides are parallel. That's given, right? So number one, ABCD is isosceles trap. And I'm sorry, this is kind of sloppy, but I'm just trying to, you should be able to write down the given. We can say AD parallel to BC, because that's given, and angle BAK is congruent to angle BKA. So let's write that on there too. B to A to K. That one is congruent to that one. And so you'll see we now got a bunch of different things. Like I know that these two sides are parallel. So we have to somehow prove that BK is parallel to CD. I got to prove somehow that these two are parallel. Well, the hint for parallel, and we've tried to talk about this a lot. We either have to show that alternate interior angles are congruent, or I have to show that corresponding angles are congruent. I have to show one of those two somehow. All right. Now, they give us that it's an isosceles trapezoid. They tell us it's parallel, and they tell us the angles. So we probably are going to have to use all of that information somehow. Well, if ABCD is isosceles, what information does that tell us? Well, that tells me that angle A is congruent to angle D. A is congruent to D. How do I know that? That's the definition of isosceles trapezoid. Those base angles have to be congruent. Well, now look. Okay, look at the picture. All right. They also told me BAK congruent to BKA, which we highlighted. So now we can tie these three angles together. A is the same as K, but A is the same as D, meaning D is the same as BKA. What allows me to tie three things together if they have something in common? Transitive. That would be the transitive property, tying things together because they both were congruent to A. So that was 3. Now I'm going to pull this off just a little bit. Here's D to C, and here was K to B. What do you notice about angle D there and this angle K right there if they're congruent? Those are called corresponding angles. So that's the reason we have now got corresponding angles theorem, our postulate, corresponding angles postulate. And if corresponding angles are congruent, these two lines have to be parallel. So number 4, we're going to say that KB is parallel to DC. So now these two are parallel. We just showed that because those two angles, here D and here K, are congruent. They're corresponding. And therefore, we now have opposite sides being parallel. So we can say BKDC is a parallelogram because of the definition of parallelogram. So this got a little bit sloppy. I didn't leave enough room. But hopefully you can see, again, we're going through a process here where we're trying to use the information they gave us, looking for some clues and hints, like parallel lines, like knowing what the definition for parallelogram is. If you have any questions, please don't hesitate to reach out. We got a lot of information coming at us all at once. Otherwise, until next time, folks, stay safe.